Implicit differentiation is our last method for calculating derivatives that we'll use this year. So hallelujah there, right? We've estimated using, we can estimate with the rate of change, average rate of change formula, right? Or we could do the limit definition. Or we can do what? I start hearing you rattle them off.
Chain, product, quotient, power.
Chain, product, quotient. What was 3.8?
I know that the estimated practice is asking for the
What?
inverse.
Oh, inverses. What was 3.9? Logs and exponentials. Okay, so we have one more.
It's the new one.
Implicit differentiation.
Ah.
Okay. So this is a case where most of the time we've given you something nice and pretty like this, right? Or we could make it a chain rule problem, or we could make it a product rule and a natural log. We can make it messy, but we've been working with y equals, right? Today is where we tackle when it doesn't say y equals. Okay, so we're going to say something like x squared plus y squared equals 1. Right, and how do we deal with that? Is what we're looking at today. Okay.
Product rule.
Is there a product in there? No, there's not. Okay. What shape is that?
Painful.
Circle, isn't it?
Circle of radius?
1.
1. Because that's r squared, right? And it's centered at 0, 0. So in fact, you know and love this as the unit circle. Oh, thanks for throwing that in there, Mr. Arthur. I hate you. Okay. Okay.
My thoughts exactly. What?
I was meant it as a joke. Gosh, you didn't have to affirm it. Okay, so that's the equation of a circle. We're going to calculate a derivative in order to calculate the slopes of these tangent lines, right? So you can do most of this already. What's the derivative of 2x?
2x.
X squared.
Yeah, 2x.
Did anybody else get tired yesterday?
Yeah.
And I'm still feeling it. Okay, what's the derivative of 2y?
2y.
Frick. Again.
2y.
It is 2y, but you're only half right.
Why?
The derivative of x squared is 2y, but here's the thing. There's something missing because we are differentiating with respect to x,
Not to y.
not to y.
2y squared.
So we have to do 2y, and then we have to put dy dx with it because we've differentiated y. Here we went differentiated x, right? So that works with this. But there 2y, we have to note that we dy dx
Okay.
equals,
1, 0.
create math murder.
Ah.
Commit math murder. All right, so that's our derivative, right? Now we will usually solve for that because we're used to getting dy dx equals, right? Or y prime equals.
Yeah.
So now we're just going to move everything.
Okay.
Okay, so subtract 2x. It's just an algebra problem at this point. Oh, stop it. These are like a bunch of 5-year-olds. Okay, and now what? Divide by 2y. And you can see the derivative does have a y in it. All right, so the value of y actually matters in the slope of this function. Okay. Evelyn.
I don't quite understand why you said it was 0. Like math murder.
What's the derivative of 1?
Oh.
0. We created math. We committed math murder. Okay. So this is the slope of a tangent line at any point on that circle. Okay. So what's the slope at? Okay, it's a unit circle, so what's the point on the unit circle for pi over 4? Well done. You're getting it. What is the, so dy dx, this is how you write this, dy dx evaluated at this point equals what? Root 2 over 2 over root 2 over 2. 1. With the negative in front. Okay. So at that spot, the slope of that tangent line is 1, negative 1, right? Yeah, we did this last year, first quarter.
How does the pi work when it's like 1 over 0?
That's a good question. One I was actually headed to. So.
Hey, buddy.
You want to teach?
Yeah.
He does not want to teach implicit differentiation.
I can't even give more than
Can I help
2
you?
multiple choice questions, right? Yeah, I'll talk to you in a second.
That works. Okay. Are you with me?
Yep.
This is not any concept that's new. It's just the calculation that's new. Okay. Evelyn.
Okay, so we already we almost finished completely the algebra.
Here.
Yeah, what happened?
We finished the algebra.
No, not that. The
What is this? Or what is this?
What is up with that?
That, okay, so this is the derivative. I have taken that point, which is on the circle, right there, right? That point is on the circle. That's this point. And I plugged it into the derivative to calculate the slope of that tangent line.
Negative x over y.
Negative root 2 over 2 over negative root 2 over, or sorry, root 2 over 2 over root 2 over 2 is 1.
I don't even know what you're saying back to.
Because I gave you the point.
Then pile four.
Right there. I gave it to you, like, here's your point. Okay.
Oh, is that always
It might give you the x and have you calculate the y.
You'll never know.
You just have to tackle that when you get there. Okay. Now, Montaigne raised an interesting question. What if I have this point where cosine is 0 and sine is 1? Yeah. That is a horizontal tangent line.
And the other one, y divided
Right.
by 0. I was saying at pi.
Yeah.
At pi, 0. Oh.
No.
You can't divide 1 by 0.
You want pi or 0? At pi?
Well,
That's
they're the same.
negative 1, 0?
They're similar.
Doesn't matter. That's 1 over
0.
0. What is that?
0. It does not
The
exist.
slope is
0.
no.
Is y. Negative 1.
It does not exist.
Undefined.
It's undefined. Thank you. No, you said does not exist. What type of line is that?
It's a vertical.
It's
straight
vertical.
line.
Yeah. Okay. So that's a vertical line with an undefined slope. So you could be asked all these points, what's the slope? Okay. You can be asked, where is there a horizontal tangent line?
Zero.
When x is 0, right? When does that happen? If x is 0, what's y? Positive or negative 1, right? So you just plug 0 in and solve. Or you could be asked, where's the vertical tangent line? That's 0 is y. Solve. Okay. Lots of different possibilities there. Same possibilities as before, just with a different calculation method.
So
Okay.
we're gonna have to use this? I'm really lost. Can we use those other ones?
The other one's what?
The other.
These?
Yeah.
We've done all those.
Can you use them?
We're going to use, yeah, these might come into play in this.
But like skipping the implicit differentiation completely.
This one does not make any sense. I should
Obey.
Wow, it's just like revolving door, man. Can I help you?
Did you put my phone with me? This one?
No, I didn't. But I'll sell you one for $200. In fact, I'll give you a smoking deal, $35. Dang it.
So close. Yet so far.
Okay. We're doing implicit differentiation. Feel free to sit in.
He's like, oh, no.
If you explain it to me, I'll probably get it.
Go away. You're protected,
Would you
right?
care to address that statement that you just made?
Oh, you want us to explain it?
Yeah.
No, he said, if you explain it to me, I'll probably get it.
Right.
Do you think he's correct in that assumption?
No.
Not yet.
Yes.
I'm telling you.
Anybody want to take that
Next
bet?
year.
Yeah, I'll take
Okay.
that
Tell
bet.
me what this is.
I'll take that bet.
It's implicit differentiation, now go away. Do you know derivative?
Oh, I'm sorry, Kyle.
Yeah, did you
Okay.
know
Let's
the
make higher people,
derivatives
she's
of
salty
that?
for no reason.
Yeah.
Let's try another one.
If you would look back, you would know why I.
Find the slope.
Why?
Because you were
Hey, well, I have a question.
Oh. Yo, Kendra. What?
I'll come speak to you later so Mr. Valdez doesn't get angry.
Thank you.
That hurt my feelings so much.
No, it'll say like that, look. So instead of saying 1 over y, you said 2 over 20.
Please just not have her
And then you just plug that in your.
It's like you have to edit all of the audio for this.
All right, so same kind of problem. Find the slope of a tangent line at 1, 1 on the graph of that. It just adds a little bit, right?
What's the application of this?
We're getting there. Come on.
Oh.
It's called related rates.
The labor?
Related rates.
Like the labor, you know, it's like.
Okay, so just do your normal derivatives, but every time you derive y, you put dy dx. Okay, so what's the derivative of e?
E of x minus y.
Okay, copy, yeah, and then times the derivative of the inside, right?
Yeah.
1 minus
dy dx.
1 dy dx. Right, because every time we differentiate y, we put dy dx. This is a chain rule. The derivative, copy the inside, derive inside. The derivative is 1 minus 1 dy dx. Some people, if you feel more comfortable, put y prime there.
Yeah.
If you want to use y prime, it is a little bit nicer. I just was taught dy dx, that's where I head. So if you want to use that, you can. Do you want me to write it that way?
Yeah.
Yes.
Okay. And then the derivative here.
4x minus 2y prime. Y prime.
That's like habit. I can't stop. Y prime. Instead of dy dx, right? Okay. There you go. All right. You can solve for y prime at this point if you want to. Does it say solve for y prime, or does it say solve for dy dx? No. Okay, so at this point, you'll plug the point in. It'll be a much easier numeric problem to solve for y prime with numbers instead of x's and y's, right? So plug in e to the 1 minus 1 okay. Does that look a little easier to solve for y prime?
Yes.
Yeah, it does. I agree. Hopefully you do too. E to the 1 minus 1 is 1. Right, that's 1. Now we have 4 minus 2 y primes. What's e to the 0? 1.
So then, can you move the y prime over and then move the 4 over?
Yeah, I would go opposite. I would add 2 y primes and subtract 1, but because it's faster, but either way works. It doesn't matter. So add 2 y primes. And minus 1. We get y prime equals 3. There's your slope.
Wow!
Dang.
Ain't that nice?
Okay.
And that's the same answer versus if you were to do it, like, if you're up there, solve it. without
Same
plugging.
answer.
That's pretty.
Ooh, scary. It's like,
It's Halloween.
there must be a clown in here.
Wow.
So you're using all your familiar methods. You're just putting a y prime or a dy dx in there when you do differentiate a y. Okay. So are we okay so far? Okay. On the AP exam, they always use dy dx. Okay, so that's kind of why I default to dy dx here.
Will we get marked out if we do y prime exam?
No, you will not, and they will score it accordingly. You are fine. Okay. One way they might ask a question is show dy dx equals, and they will actually give you the answer. And you will just do the algebra. Right. So let's run through the algebra here. Okay. Didn't have to, but I want to run through that with you just so you have that in your melons. If we can. Can I isolate y prime? Actually, I can. I have to distribute first. Right? So I have e to the x minus y minus e to the x minus y times y prime. See, these can be bearish algebra problems, right? That's why I plug it in first, if I can. Okay. I'm going to move this y prime over here, and I'm going to move this e to the x minus y over here. Right, so I have 2y prime minus e to the x minus y prime. 4x minus e to the x minus y. Right, so I just shifted 2 things. Evelyn. Deer in the headlights. What's wrong? It's not hardest. It's not the hardest. It's pretty darn close. This is pretty darn close to one of the harder things we'll do this year. Okay. I'm not going to tell you so that you don't have it in your brain when you come in here that day.
Okay.
Can I get like a time frame as when it will be?
Back out of y.
It might be in the next 24 hours, but it might also be in the next 6 months.
I'm nervous.
Okay, so it's in the next 6 months.
We're gonna learn the hard
All right.
stuff this year.
Do you understand what I did there?
Yeah.
Okay, now can I factor a y prime out?
Yes.
So y prime factor, what's left? 2y minus e to the x minus y?
Yeah.
And now I can divide by this, right? So I'm going to write that in red just so you see it, because this is where a lot of people get screwed up. Right, so those will cancel now. And all I'm left with is y prime equals that. Okay. That, which is easier, plug in and do it, or do the algebra and plug it in?
Plug in.
Right. So if you have the opportunity,
Plug it in and do it.
plug it in and do it.
So
Okay.
when do you know that you can't?
So if I plug 1, 1 in here,
You get 3.
I would get 3.
Really?
Yeah.
So
4 minus.
if
4 minus 1 and 2 minus 1.
Yeah, okay.
1 minus 1 is 0. E to the 0 is 1. So the AP test might say show dy dx equals, and they will give you this answer. Your job is to do that. Okay? Just a tip. Right? Okay, so a couple different situations. You're still applying your product rule, chain rule, quotient rules. Okay, so you might run into something like
what we just did.
that was a chain rule problem. How about this? What rule are we going to use here? Power rule and product rule, right?
Will they always be double-sided like that?
Usually, yeah. Okay, so yeah, we have power rule here, right? 4y to the third. What goes with it?
Plus 1.
Y prime. I differentiated y.
Oh, wait, so you always do derivative of x first?
And just on this dude.
No, I'm saying like, when you do these, you derive for x, and then you have y prime.
Yeah, that's pretty much the thing. If you don't differentiate with respect to x, you're not going to get the slopes right. Okay, product rule, right?
Alright.
So derivative first is 1y plus x. What's the derivative of y?
Y prime.
1y prime, you can just write y prime, right? And then, okay. So, you might run into product rules and quotient rules and all sorts of stuff like that.
It's really stuff.
Another question you could get, where is there a horizontal tangent line? This is where you have to solve again. With solve for y prime. Okay. So I'm going to move y over here to isolate these terms. So all I've done is move that to this side. Isolate these. Okay, what do I do now? That factor. And now? I'm trying to hurry because I don't want the bell ringing on it. Divide, right? Y prime equals 3x squared minus 1 minus y, 4y cubed plus x. where is there a horizontal tangent line? What would I need to do to this fraction? Yeah, but which part of it? What? When does a fraction equal 0? When the top is 0. Am I ever going to get a solid x equals or y equals point? No, because I have two variables, right? So once you get this, you have to plug back into the original.
So why don't you just
The
disregard?
system of equations. Okay. So plug into original.
Well, you have to substitute for y then?
Yep.
Okay.
So that's substitute. Yeah, that was the term we used. And solve.
Why are you only doing the
Okay.
top?
That's what I asked you to do. You could do where's the vertical tangent line, right? Same thing. Except the bottom equals 0. System of equations.
But you look into, like, the original one. given-
Yeah, so I would put this right here in for y. Like up there, right there. And it makes ugliness. But you're going to put everything on left one side and probably going to get a calculator for that one. Okay. I don't think we have time to do that, so. And I don't know if they asked that of you, to be honest with you. Okay. So, use the methods you know, just put y prime every time you differentiate y. Okay? Do you want me to try to finish that?
Yeah.
Okay. Let me write down the homework. It's on Classroom as well. Okay, I'm going to make that due Tuesday, because I know you're tired. So there are way too many of you are doing half homework or none of it. For your own sakes, you gotta at least try. Okay. Okay. I bet you $10 the bell rings in about 2 minutes.
That's okay.
Okay, so I have that monster to put in here, right?
Oh, and that's there?
Yep, that's, so we put this into the original.
Okay.
So we have 3x squared minus 1 to the 4th plus x. Oh, I was close. Okay. Again, you're going to move this all to the right side and set it equal to 0. So we need 0 equals. Then you can put it in your calculator. And you can do zeros. You remember how to do that from last year? Calculate zeros?
Yeah.
That's what you're doing.
She's like, don't worry, I won't.
Thanks for listening. Bring questions tomorrow. Always.
Are you actually?
But you can come in and get help if you need to.
So you would distribute this, all right?
You don't need to.
You don't need to?
You can move it all to the right and put it in the calculator as is. Or you could do that and combine it like this, it would be cleaner.
Okay.
That would be fine. So,
And then you just distribute
I
that?
no, that's, just leave it.
Okay.
Yeah, so, part of what you're trying to do is just save time.
Yeah, of course.
Let your calculator do the work.
Okay, so let's move that
I
over
just
and
moved it all
then
over.
plug it in.
Throw it in, 2 zeros.
Okay.